Hello all, let's start the last part of section 5.3. In the last part of section 5.3, we cover case 4. Case 4 of partial fractions. Case 4, if I put a topic for you, the partial fraction decomposition when the first partial fraction decomposition of p of x over q of x, when your q of x has let's say a prime repeated quadratic factor. Correct? It means if you have p of x over ax squared plus bx plus c to the power of n, it's a repeated quadratic, prime quadratic factor, then you write this way. The first one becomes a1 x plus b1, here ax squared plus bx plus c. The second one, a2x plus b2 and ax squared plus bx plus c to the power of 2. And if you have more, the last one of course will be anx plus bx over ax squared plus bx plus c to the power of what? N. The only difference is how to set, right? After that, it's easy, the same. You follow the same steps like case 1, case 2, and case 3 to can write our partial fractions. Now, I'll do an example. In the previous lecture, I just went halfway for you, left it for you to finish. Hopefully you would do that, because the main important part is how to set. Then after that, when it becomes a two-variable system of two-variable linear equation or three-variable, that part is easy to deal with. Let's copy this example from your book. 5x cubed minus 3x squared plus 7x minus 3 all over x squared plus 1 all square. X squared plus 1 all square. You see, x squared plus 1, it's a quadratic, it's a polynomial quadratic. You cannot factor it anymore. It's a prime quadratic, right? And it has a square. When it has a square, it means it's repeated, right? Then how to set my partial fractions? First of all, how many of them I need? You need 2 of them. This number shows you need 2. Then you go this way. 5x cubed minus 3x squared plus 7x minus 3 all over x squared plus 1 all square equals 2 fractions that you need. The first one, the denominator becomes x squared plus 1. The second one, the denominator becomes x squared plus 1 all square. Correct? And the top of the first one, because the denominator is quadratic, you should put a linear in the top, then ax plus b. The second fraction, you have a quadratic in the denominator, then this one becomes cx plus what? D. Now multiply both sides with your LCM. Multiply this side with x squared plus 1 all square, and multiply this side with x squared plus 1 all square. As you see, these two cancels out. Then 5x cubed minus 3x squared plus 7x minus 3 equals, one of them cancels out with one of these, then what left? Ax plus b times x squared plus 1 plus both of them cancels out with both of these, what left? Cx plus d. Now simplify the right side, then equate both sides, equate the coefficients of both sides, right? 5x cubed minus 3x squared plus 7x minus 3 equals 5. Ax times x squared gives you ax cubed. Ax times 1 gives you ax. B times x squared gives you bx squared. And b times 1 gives you b. Correct? Plus cx plus d. Now equate both sides, or first you can order it also in descending order, right? If you want to go step by step. 5x cubed minus 3x squared plus 7x minus 3 equals ax cubed plus bx squared plus ax plus cx plus b plus d. Correct? The coefficient of x cubed, which is a, you equate with the coefficient of x cubed on this side. It means you can write a equals 5. Oh, at least I have one of the values. The coefficient of bx squared equates with the coefficient of x squared on this side. It means b equal what? 3. The coefficient of x's, which here you can simplify it as a plus c, you can factor out x. A plus c equals to what? 7. A plus c equals 7. And your constant term, which is b plus d, equals to the constant on the left side. It means minus 3. Now solving this system is really easy because you know the value of a. If you plug in the first equation, or actually this is the third equation, not the first. This is 1, this is 2, this is the third, this is the fourth equation, correct? If you plug in a in this equation, you can get easily the value of c. And if you plug in b in the equation number 4, easily you can find the value of d. Let's do that. Then 5 plus c equals 7. Subtract 5 from both sides. It means c equals 2. And also you have b plus d equals negative 3. If you put the value of b here, 3 plus d equals negative 3. Subtract 3 from both sides. Then your d equals negative what? 6. Now, go back to equation that you have in step 1, right? Your equation in step 1 was 5x cubed minus 3x squared plus 7x minus 3 all over x squared plus 1 all square equals ax plus b over x squared plus 1 plus cx plus d over x squared plus 1 all squared. Replace or substitute the value of a, b, c, and d in this equation. It means it will equal to, how much was a? Our a is 5, right? Then here I will write 5x plus b. How much is b? b is 3 over x squared plus 1 plus cx. How much is c? 2. 2x plus d. How much is d? Minus 6. It means minus 6 over what? X squared plus 1 all square, and you're done. Correct? This is how you deal with the partial fractions when your denominator, or q of x, has a repeated prime quadratic factor. Right? This was really a short lecture for you. I'll stop the lecture here, do your homework, and you will be okay. Stop the lecture here and see you all in section 5.1.